Hello and welcome to our SOL review of A.09, mean, standard deviation, and z-score. And if you notice, I have a pretty funny looking thing drawn in front of me, and this is actually called a bell curve. And we're going to get a little more into that first, but let's talk about some symbols you might see, because you might be looking at those thinking they're kind of funny, and just what it all exactly means. So speaking of mean is represented by two symbols, either X with a bar on top or this funny looking U shape. Mean is the average of the numbers. You usually did this by hand by adding up all the data points and dividing by how many data points there were. Standard deviation, which I like to call fat R, standard deviation is how spread out all the data points are from the mean. And z-score is kind of a cool way to use the standard deviation to compare data sets. We're going to get into z-score a bit more. There's even a formula that you're going to learn, and thankfully it's given to you on your SOL. So back to our bell curve. The very center of the bell curve, the longest bar if you will, the very middle, is what the mean is. So I'm going to go ahead and label that the funny U, and in this problem the mean happens to be 30. Now in each direction of the bell curve we're either adding or subtracting the standard deviation. So in this direction we would have to add 1 standard deviation, and in this direction we would add 2 standard deviations. In this direction we would add 3 standard deviations. So this would be 30 plus 5 is 35, this would be 40, and this would be 45. And then going the other direction we would subtract standard deviations. So 1, 2, 3, we're going to slide that 2 in there. So this would be 25, 20, and 15. Now z-score comes into play. Z-score is between -3 and 3. It's a number. And if you notice, this goes from -3 to 3. That's because z-score has to do directly with standard deviation. So let's suppose I tell you that there's a data point and it equals, 33. Well, the z-score formula looks like this. Z equals the data point minus the mean, all divided by the standard deviation. So all we have to do is just plug in the necessary information to get our z-score. So we happen to know that X is 33, and we happen to know that the mean is 30, and the standard deviation is 5. So when we start cleaning this up a little bit, we'll get 3 divided by 5. So this is a z-score of 0.6. And now if you think about where the data point would have fallen, 33 is right around here. That makes sense because it's not quite a full standard deviation away, or 1, so that makes sense that it's 0.6. So it just kind of works out that way. That's kind of how z-score works. Again, you're given this formula on the SOL, so you don't have to worry too much about it. Speaking of SOL, let's take a look at a question. So each of these data sets has a mean of 20. Order the sets from greatest standard deviation to least standard deviation. Alright, so to do this, we're actually going to go ahead and use our calculator. And before I get started with that, it might be a good idea to pause the video and write down each data set so that you can follow along, because I am going to kind of put them off screen a little bit harder to see. So, here I have a TI Nspire, and this is what I'm going to be using for the demonstration today. So I'm going to make a new document, and if this pops up, you never want to save documents, so just go ahead and say no. And we're going to add a list and spreadsheet. Anytime you have to type in data, you must use list and spreadsheets. So there we go. So what I'm going to do in the calculator here, the very first column, I'm going to just type in the first data set, which went 18, enter, 19, enter, 20, enter, 21, enter, and 22. So I've typed in all 5 numbers. If you want to go ahead and give a label to the column, it's never a bad idea. You can go ahead and make it something like X or Y or any letter you want. X, there we go. Make it X. I really think it's a good idea to make this column X because, as you've probably seen in other videos, this column is usually reserved to input Y. Alright, to type in our data, or to calculate our data, what we're going to do is we're going to hit the menu button. We're going to go to Statistics, Stat Calculations, and One Variable Statistics. We only typed in one list, so it makes sense that the list is 1. Now it's important to make sure that this either says A, or if you want, since we labeled it, you can actually click on it and make it X. It's the same thing in this problem. But you want to make sure that this is the list where you typed in all of your data. So we're going to go down and hit OK. So we're able to get the mean, which is 20, and the problem actually told us that. It said each of these data sets has a mean of 20. But we're going to scroll down until we see that standard deviation symbol. There it is, right there. So the standard deviation of the first problem was 1.41. All right, so now we're going to go ahead and repeat the process for the next two problems, except I'm not going to do it for set 2. If you notice, set 2, every single number is 20. Standard deviation is the spread of data. Well, since all the data is in the same place, it's not actually spread out. This has a standard deviation of 0. So while this had a standard deviation of 1.41, set 2 doesn't have any standard deviation. Don't believe me? Type it in your calculator. Let's go ahead and calculate the last set of data. So again, new document, do not save, and we're going to use a list and spreadsheet. Label the first column X. There we go. And I'm just going to type in the numbers as they appeared. So 16, 18, 20, 21, and 25. The nice part is you don't have to make sure they're in order either. Hit Menu, go to Statistics, Stat Calculations, and it's the very first one. Enter. And again, I want to make sure that this list is X. Awesome. And there it goes. So the mean again was 20, and if I scroll down to where the standard deviation symbol was, we see that it's 3.03. So on my paper, I can go ahead and write that down. And the question asked us to order the sets from greatest standard deviation to least standard deviation. All right, so the greatest was set 3, so set 3. Then next would be set 1, and the last one would be set 2. Now, as a little bonus question, I've thrown this in here. How many data points were below a z-score of 1? And we're going to go ahead and use data set number 3. So, what we need to recall are the 3 pieces of information. We need the mean. So the mean in this problem was 20. We need the standard deviation, which was 3.03, and then we also need a data point, but we're actually trying to figure out what the data point is because they gave us a z-score. So z in this problem is going to equal 1. So the formula, which I'm going to go ahead and write in this gray bar, z equals x minus the mean divided by standard deviation. For us, it's going to be 1 equals, we don't know yet, minus 20 divided by 3.03. You can see we're trying to get at the x. So I'm going to multiply both sides by 3.03. So on the left, I'm going to end up with 3.03 equals, on the right side, this cancels out, x minus 20. And so for the last part, what we're going to do is we're going to add 20 to both sides. So the answer is 23.03 equals x. So let's go back and look and see how many data points were less than 23.03. 16 was, 18 was, 20 was, and 21 was. 25 was not. So, to answer the question, how many data points were below a z-score of 1? The answer is 4. Thanks for watching.